Today we are going to explore and investigate physical and chemical changes. Physical changes are changes that affect the physical properties of an object or substance, such as an appearance, size, shape, or form. No new substances or materials are formed when a physical change occurs. Some physical changes are reversible and some are not. And evidence of a physical change could be in size or shape, texture, color, or phase changes of states of matter, such as solid, liquid, and gas. A chemical change is when a new substance or material is produced. It may also affect the physical properties of an object or substance. Some are reversible and some are not. And evidence of a chemical change can be production of a gas or bubbles, light appears, color changes, absorption of heat, temperature changes, or smell is produced, etc. In this video, we are going to watch examples of physical and chemical changes that you may see out in the real world. Using your knowledge of physical and chemical changes, it is your task to decide which examples are physical changes and which ones are chemical changes. The first change you are going to be investigating is an ice cube melting. Did you think that was a physical change or a chemical change? Let's review what we saw. As the ice cube melts, it changes from a solid to a liquid. It also changes in shape and size. This change does not produce any new substances and does not change the composition of the matter. It is still water. Therefore, an ice cube melting is a physical change that is also reversible. The next change we will be investigating is cooking an egg. Did you think this was a physical or a chemical change? Let's review. When we cook an egg, we see that the appearance changes, including its color and texture. The egg is also absorbing heat, which is causing the temperature of the egg to change. The raw egg that was clear has now become a cooked white egg. A new substance has been produced. Therefore, cooking an egg is a chemical change that is irreversible. The next change to investigate is breaking a glass. Did you think that was a physical or a chemical change? Let's think about it. When we break a glass, the appearance and shape has changed. The texture has also changed because now we have a part of a glass that is very sharp and could be a safety hazard. There was no new substance or material formed, and the matter of this object is still only glass. Therefore, breaking a glass is a physical change that is also irreversible. The change we are exploring now is chopping wood. What did you think? Physical or chemical? Well, when the wood is being chopped, the physical appearance is being altered, including its shape and size. There is no new substance being formed. And even though the wood has been cut, the chemical composition of the matter is still the same. It is still wood. Based on this evidence, this is a physical change that is irreversible. The next example is burning wood. Is burning wood a physical or a chemical change? Well, when we watch the wood burning, we notice that the wood's appearance is changing, including its shape, size, color, and texture. We can also see that there is gas being released called smoke. Smoke produces a smell. The burned wood is being transformed into a new substance called ash. Therefore, we know that burning wood is a chemical change that is also irreversible. The next change to investigate is mixing yeast, sugar, and water together. Is this a physical or chemical change? When the yeast and sugar and water combined, the first thing we saw were bubbles being produced. Then a foamy and fluffy new substance formed and began to rise to the top of the liquid. The ingredients reacted with one another and created a new substance. This is similar to how yeast causes bread to rise when we bake. This means that this is a chemical change that cannot be reversed. Can you think of another physical or chemical change that you have seen in the real world? How did you know if it was physical or chemical? Think of an example for the class to investigate next.